Our next type of weather system that we'll look at are the hurricanes. In contrast to a tornado, hurricanes are very large, but like tornadoes, we have fast winds. They are rotating, they are cyclonic systems, a low pressure system. Hurricanes specifically are tropical. And the cutoff wind speed is defined as 120 kilometers per hour. Now, these different names, hurricanes are what we call them here in the Atlantic and also in the Eastern Pacific, as in the coast of the Americas. In the Western Pacific, they are known as typhoons. And then Indian Ocean, they are called cyclones, which of course is also our general term for low pressure systems. Besides hurricanes, if it's not as fast wind speed, it's a tropical storm. Now still 100 kilometers per hour, that's quite a respectable speed. That can still be damaging wind. And then below that, you've got a tropical depression or tropical disturbance. Hurricanes, the energy derives from the evaporation of warm water. So they're going to form someplace where there is very warm water out in the ocean. Of course, these days, global warming, there are more places with warm water. We're seeing them occur more frequently further out from the equator. Hazards associated with hurricanes, of course, the winds. And when you have winds like that going, that can create smaller spin-offs. And so some hurricanes do cause tornadoes. There were around 20 detected by the weather radar in Sumter, South Carolina, for example, as Hugo came through before the weather radar was wiped out by Hugo. The heavy rain, even if the wind is quite weak, you can have lots and lots of rain. This was vividly demonstrated by Harvey hitting Texas a couple years ago. The Weather Service actually had to add extra categories for even more rain than they had before because the system just sat there and poured rain. It wasn't windy, but had the flooding. And the storm surge. Again, this is extra high ocean level because the storm has blown water in front of it. Also, the low pressure means the water is going to tend to push up somewhat more. And that effectively raises sea level where a major storm, such as a hurricane, comes close to or onto land. And of course, raising sea level, then you've also got the tides and the waves from the storm on top of that, making the total height even higher. They are primarily impacts for the coast. However, these systems can blow inland and have significant effects elsewhere. Here in Hugo, for example, went right over Carter's Mountain area, and so had significant impacts on Cleveland County and on campus itself. But areas that are going to be most vulnerable are low-lying areas near the coast. As Katrina showed, New Orleans, actually below sea level, from sitting on a delta that is sinking, very readily flooded. Similarly, my mother-in-law grew up in South Florida and can remember a hurricane coming through and dumping water in this area would be flooded. In the 80s, we had several years of not having any big hurricanes. And then 92, Hurricane Andrew comes through. Guess what? Those same places got flooded. Except people had built houses in them in the meantime. Not good. Storm surge has a particularly noticeable effect on our coast here in North Carolina. Hurricanes coming in, it's a low pressure system. We're in the northern hemisphere, so those winds are coming in counterclockwise towards the low. Good old Coriolis effect. Earth's still spinning. Okay. Form in warm areas, that's typically more to our south. So hurricanes typically are coming up from the south, counterclockwise into the low. The north side of that hurricane will have winds coming from offshore. So that's pushing the water on in up, and we get extra water pushed in past the Outer Banks into the sounds along the coast. Okay, hurricane continues to move north. Wind direction on the south side of the storm is opposite. So not only is this extra water going to drain back anyway, and water not good for trying to make hills, but the wind's actually pushing it out. So we have quite a strong drain back, and sometimes the water doesn't bother going all the way around to the inlet, and instead erodes a new path right through the island. Now, of course, the island's just a pile of sand out there with nothing particular on it. Okay, sand's rearranged. But if somebody's got their beach house there, or the highway, putting a new channel through the island becomes unpopular. This is a pole illustrating storm surge. It's down at the North Carolina Aquarium near Wilmington, Fort Fisher there. And these marked points are how high the storm surge would have been if it had hit right at the aquarium there. So, for example, Bertha would have had about a foot of water above the ground at the aquarium. Would not be a good time to visit. Fran, on up to there, you can see it's 12 feet above sea level, and the ground's only about 4 feet. So that would be 8 feet of water. You would not want to be standing there. Hurricane Hazel's storm surge is close to the tops of the small trees there at the aquarium. And that's how high sea level would be, not counting the tides and the waves on top of that. Definitely would not have been a good time to be at the aquarium if Hurricane Hazel had come in right there and you had the storm surge at that point. Another very vivid demonstration of this came with Hurricane Hugo. An elementary school, the map said it was at an elevation of 20 feet, which is pretty good for being near the coast in South Carolina. And so it was designated as a shelter for people to head to in case of storm. So a lot of people were in school. Only problem was the school was actually at an elevation of 10 feet. The map and elevation, they had copied the building plan from another school and had copied the elevation. So the information was wrong on what had prompted folks to think that it was a high spot. And it turned out the storm surge there was 16 feet. School at 10 feet, storm surge 16 feet. There were 6 feet of water in with the storm refugees. And they were wet and not real happy. They survived, but it was not a fun experience. Again, hurricanes get their energy from warm water. So, the warmer the water, the stronger our hurricane can be. As an extreme case of this, back with the end of the dinosaurs, you crash a great big asteroid into the ocean. That generates a lot of heat. And so you would have had extremely hot water, and it's been suggested that you could have had giant hurricanes with winds going something ridiculous like 600 miles an hour. Good thing we don't have that now, but warmer water does potentially give us bigger hurricanes. Hurricane has to start somewhere. Get a low pressure system. All sorts of variations, even just the one bit of the ground gets warm, the other air above it rising, your standard summer thunderstorm type of situation. whatever, we get a weak low system. And this is known as a tropical disturbance if it's in a warm area, not associated with a front. Now, here's a slow. If it runs into some other sort of weather system, it's pretty small at this point, it can be broken up, nothing happens. If it moves over land, land is not warm water. It can't evaporate and contribute the latent heat going into the hurricane as it condenses after having evaporated and risen. Colder water. We don't have enough evaporation to sustain the hurricane. But if instead our weak low pressure system stays over warm water, it can strengthen and build and become possibly tropical depression, tropical storm, hurricane. Now, exactly what it's going to do in terms of strengthening or weakening is quite challenging. We're actually going to focus on that in lab, but just to note, it doesn't automatically, the longer it's been around, build up stronger. They go up and down in strength. Some can strengthen quite fast, some never strengthen. It is not something easy to predict, especially more than a few days in advance. Again, with warm water, we've got the evaporation, all that water vapor up in the air, very unstable air, so it's rising rapidly, and when it gets high enough to cool to the dew point, lots of water condensing, so it's releasing latent heat. That air can't cool down, it's still unstable, it's going to keep rising right up and give us this great big storm system. As that air rises, other air comes in to take its place, Coriolis effect, so it bends it as it comes in, and we get the spinning pattern of our hurricane. Again, lots of rain is a major problem. In fact, according to the insurance companies, the freshwater flooding associated with the rain is the biggest cause of death in 70 to 1999 from tropical storm systems rather than things like the wind and surf, tornadoes, direct being caught in the storm surge or being out on a boat. Again, not necessarily much wind, but a lot of rain. When I was up in New York, inland New York, so you're not very likely to get a actual hurricane there, but we had a tropical depression, remains of a tropical system that moved over where we were and rained, and there was serious flooding. Now, our house was up on the hillside, several hundred feet. We kind of laughed when the insurance company called, wanted to know if we wanted to get some flood insurance. If we were flooded, the whole East Coast is already drowned, and the insurance company is probably not in business anymore. So we were not at risk, but down by the lake, the grocery store had parking spaces underwater for about a month. There was significant flooding there. Hurricanes, of course, do significant damage, but you do have problems of, is the response actually entirely appropriate?